Hello again everyone, welcome back to ptet.chemistry channel. So my name is Dr. On, and in this tutorial video we'll go through these multiple choice questions. It's a bit longer for 40 question MCQ, which is typically 1 hour for the 5070 or any associated 14 to 16 years old chemistry curriculum, which include the IGCSE for instance. So what is happening is that because this topic is on reacting masses, reacting volumes, all those calculations, accordingly you need a little bit extra time in order to allow for all these calculations to be done as correctly as possible, hence a slightly longer paper. Okay, so before I start, so do click the button on the bottom right to subscribe to the channel, and please share the channel widely with everyone you know who can benefit from the contents available on the channel. And you can follow me at ptet.chemistry. There's at ptet.chemistry on Facebook, Instagram and Twitter to get connected and send in your questions. Let's get started with this question number 1. So what is the mass of 1 mole? So in 1 mole of carbon-12, carbon-12 refer to this isotope. Isotope was a topic covered in atomic structure. The way we write it in the context of international standard, carbon is element number 6, so the proton number is 6, so we write down 6 at the bottom there. Unlike the format that appear in your periodic table, you write the 12 on top because that is your nucleon, or that is your mass number, whereas your atomic number or your proton number, you write it at the bottom. So there's just a brief overview of what you have done in atomic structure in the last couple of topics. So carbon-12 means that 1 mole of it would have a mass of 12 gram. So very clearly, D is the only obvious answer, because in 1 mole of it, you have Avogadro's number of particle. So you have Avogadro's number of these carbon-12 atoms, and therefore they'll have a mass of 12 gram. Question number 2, iron trichromate is this yellow solid. They say it contains this ion and this ion. So this is basically about how do you combine ions, knowing their formula, which are given here. If you think about the charges here, is a +3, the charge here is -2. So your job really is to do lowest common multiple, primary school mathematics and the lower secondary mathematics. How do you cancel out the charges? By finding the common factor. So when we did this cross multiply thing, which you would have done in classes or in lessons, we just bring down the number or the value on this -2 is 2, so you go to the other side. The number on +3 is just 3. You bring down the number, you do not bring down the ions, you do not bring down the charges, you bring down the number or the value on the charge. So what this actually means is there's 2 of this Fe3 plus, and what this actually means is there's 3 of this CrO4 2 minus. Looking at that, then you will be able to deduce that there are 2 of the Fe3 plus and there are 3 of that CrO4 2 minus in a bracket. When we write final formula, we don't show the charges on the ion, so it's Fe2. But for polyatomic ions, which include all those nitrate, sulfate, phosphate, everything was in your syllabus, everything was covered in the classes a couple of months ago in all those lecture tutorials leading up to these topical tests. So it's Fe2, CrO4 3. The name of it will be iron trichromate. Iron 3 means the valency of iron. There is iron 3 plus, and therefore we're looking at +3 valency there. So Fe2, CrO4 3, that's option D there. Question number 3, formula of some ions are shown. So in the real thing, you are usually not given this kind of table at all. You gotta know carbonate. So CO3 2 minus is carbonate. So you cannot rely on the question ever giving you a table like this. Never ever at all. The bottom bit there, SO4 2 minus is sulfate. S2 minus is what you call sulfite with the IDE. All of these just cations. This one is particularly special because it belongs to transition metal. So we're going to write in a Roman numeral for the particular charge of the cation. Just like the previous question, we have iron 3 here because it's iron 3 plus here. So which of the following is not correct? So you got to read the question carefully. aluminium sulfate. If you look at aluminium and the sulfate, so you have plus 3 and minus 2. You cross multiply the value, so you got 2 of this aluminium 3 plus. I could go on and on, but I'll probably not do for all of them. I'm just going to show you for 1 or 2 more example, and you get the hang of it. So there are 3 of this sulfate for 2 of this Al3 plus 3 and plus 3 give you plus 6, minus 2 minus 2 minus 2 give you minus 6. That's why the overall compound has no charge, even though it's ionic compound, because the total charge of the cation must cancel out the total charge of the anion. Compound has no charge. 2 of the aluminium 3 plus, 3 of the sulfate. This is correct. This is correct. A is not the answer. Calcium nitrate, Ca2 plus and not 3 minus. Like that, when you cross multiply, you bring down the value on the charge, the number, and you bring down the value on the charge for calcium 2 plus to the other side. You're doing lowest common multiple. You're doing a primary school mathematics. Your objective is simple: cancel out the charges of the cation with the right number of anions, or vice versa. So calcium nitrate, 1 calcium 2 plus and 2 NO3 minus is correct. Iron 3 bromide. Iron 3 means Fe3 plus, bromide is Br minus, so plus 3 and minus 1. And you're going to cross multiply the value on the charges. This means 1 of the iron 3 plus and 3 of the Br minus. So Fe3Br is definitely wrong, and C is the answer because it should be FeBr3, 1 of that and 3 of the Br minus, which means this last one must be correct as well. I'll very quickly show you what I'm talking about. Potassium sulfite with the IDE is with the S2 minus. Even without this table, this is from a table of ions that you're supposed to have mastered by now. It's a group 6 element, so they want to get 2 electrons to get to the fully filled outer shell. So you cross multiply the charges, not the charges, but the value on the charge. So there's 2 going to the K plus and 1 going to the S2 minus. So this means there's K plus, and there's only one S2 minus, so it's K2S, and that's correct, obviously. And we already worked out the answer C. We don't really need to check for D. I was just showing it for completion, just so you know why D is wrong. Question 4, so you're looking for the greatest number of molecules. Molecules there is not atoms. So hydrogen is H2 molecule, as you know from covalent bonding topic, which you have done all the dot and crosses, which you have mastered everything in the syllabus from bonding, because they say candidates should be able to state all this formula of common elements and common compound. So H2 is an element. The dot and cross is when the hydrogen atom wants to complete the outer shell with 2 electrons in the outer first shell. 80 grams of water. Water is this compound consisting of oxygen and hydrogen. Oxygen form 2 covalent bonds because they want to share 2 out of the 6 valence electrons, where oxygen is 2, 6, hydrogen is 1, and then this one want to share 2 electrons. The hydrogen want to share 1 electron. So you can imagine water, H2O, being hydrogen forming single covalent bond, and you need 2 hydrogens to have satisfy the oxygen sharing 2 electrons like that. And when you use 2 out of the 6 for covalent bonding, for sharing of electrons, then you still have 4 more, because counting is already a primary school mathematics. Oxygen is O2, so oxygen is like that. I'm not going to bother drawing dot and cross for you anymore. And CO2 is just like that. So carbon with 1, 2, 3, and 4 covalent bonds, because carbon is group 4, it shares 4 outer shell electrons. Oxygen is group 6, it shares 2 outer shell electrons. Both of them, the objective, sharing of electrons between non-metal and non-metal, is what you call covalent bonding. The purpose of covalent bonding and sharing particular number of electrons is to both achieve or obtain the noble gas electronic configuration. So looking at that, we really has to be working out the MR of H2, which is 2 times 1 is just 2. The MR of H2O is 1 times 2 plus 16 is 18. MR calculation is stated in this topic, something that you'll be able to do provided you know the formula. The MR of O2 is 32 because 16 times 2, because that's the atomic mass for one oxygen. You have 2 oxygen atoms in one single molecule. The MR of CO2 is going to be 12 times 1 plus 16 times 2. You're going to get 44. So what is given here are masses. So what we can do is work out mole. Mole equal to mass of MR. So the mole there is 4 gram over 2. I get 2 mole for A. And then for B, I get 18 gram divided by the MR. That is 1 mole. For C, what do I get for C? Let me just move that to the other side first. C, I have 24 dm cube. So this is a gas at room temperature and pressure. It's given in your data booklet. Sorry, not data booklet. I was thinking about A level. It's given in your periodic table. At the bottom of your periodic table, 1 mole of any gas is called molar volume. It's 24 dm cube for 1 mole of any gas at room temperature, at pressure. Okay, so this is given for free, but you must know it in your calculation that at room temperature and pressure, the mole of a gas is going to be the volume of the gas in dm cube divided by the molar volume in dm cube per mole, which is 24. That gives you 1 mole of oxygen gas. Next up, I have the mole of CO2, so 66 over 44. So there's 3 over 2, that's 1.5 mole. It's also stated in the syllabus that candidates should be able to relate the formula. So the number of molecules is Avogadro constant, 6.02 times 10 to the 23 times the number of mole of molecules. So for A, B, C, and D above, I've worked out the exact number of mole of molecules. Without multiplying by Avogadro constant, I can see that the biggest number of mole is going to give me the biggest number of molecules. So, there's literally no need for you to work with 6.02 times 10 to the 23. It's better to work with mole. Find the biggest mole of the molecules. Then you will get the biggest number of your molecules, because this is just a constant. So A must be our answer there. Question 5, diamond is a pure form of carbon. That is from your chemical structure and bonding topic. You have different forms of the same element. So you have diamond, you also have graphite being the other form of carbon. So the mass of diamond can be measured in carats. 1 carat is 0.200 gram of carbon. So you want to know how many carats will give you 6.02 times 10 to the 23. This is Avogadro constant, number of atom. So this is math essentially. So what do we know? We know that in 6.02 times 10 to the 23 atoms, how many mole is that? So the mole of the carbon atom is going to be how many atom you have divided by Avogadro constant, which is the exact same number. So you have 1 mole of carbon atoms. So what do we know? Number of carats that contain 6.02 times 10 to the 23. So in 1 mole of carbon atom, you have 12 gram, because there is the relative atomic mass of carbon atom. So 1 carat is 0.200 gram. So 0.200 gram is equal to, if I just use a ratio, 0.200 gram is 1 carat. If I have 12 gram of carbon, so I'm gonna have 1 carat times 12 over 0.200. So 12 divided by 0.200, that's going to give me the exact number of carats of carbon atom. A lot of students, they look at this number, they think the answer must contain the Avogadro constant, but you must ask yourself, what does this number actually meaning? How does it relate, or what's the reference or relationship to the number of mole? We like to work with mole because there's your definition, relative atomic mass as well as relative molecular mass, your gram per mole. Follow the units, and the units will allow you to define what you want to know. Question 6, we are looking at these calculations involving gases. So this is at room temperature and pressure, the molar volume of any gas at 25 degrees Celsius and 1 atmospheric pressure. There's just room temperature and pressure. There's 24 dm cube, because it's the volume for 1 mole of any gas. So you want to look at occupying a volume of 3 dm cube. You want this volume of 3 dm cube. So these are all given as masses, and masses. So we know that the mole of a gas as the mass of a mR is going to be the same as the volume of the gas divided by the molar volume of the gas, because this is given the mass of the gas, this is given the volume of the gas. I want 3 dm cube. This is my target. My target is 3 dm cube. Molar volume of the gas is constant, so 24 dm cube per mole. I don't know the masses, so essentially what I can do is I can work out 3 over 24. So the mole of the gas that I want is 3 over 24, 3 dm cube divided by 24 dm cube per mole. Get 0.125 mole. So for each of these, I need the MR. So the MR of O2 is 16 times 2 is 32. The MR of N2 is 14 times 2 is 28. The MR of SO2 is 32 times 1 plus 16 times 2 is 64. The MR of CO2 is 12 plus 16 times 2, that is 44. So given the masses, mole equal to mass of MR, so what you can do is you can work out for each of these things. So the mole of O2 there is 3.2 over 32, mass divided by the MR. So this gives me 0.1 mole. I want 3 dm cube of gas at room temperature and pressure divided by 24. I'm looking for 0.125 mole. This is not 0.125. A is not the answer. So let's move on. B, the mole of N2 is 28 over 5.6 divided by 28. I just press my calculator and I get 0.2 mole. So again, B is not the answer. So how about if I try the next one? So C, so 8, so the mole of SO2 is 8.0 divided by 64. So 8.0 divided by 64, I get 0.125 mole, which is exactly what I need based on the 3 dm cube of the gas. So C is the answer there. You could check for D, but I already got my answer, so I should move on. Question 7. Number of molecules in 500 cm cube of oxygen. Careful, there is 500 cm cube. So what I do is find the mole of oxygen under room conditions. Oxygen exists as this diatomic molecule as an element because your oxygen atom has incompletely filled out the shell. That was the reason why you did bonding, and then you did formula, and then you are doing calculation now so that you know all these things are related. So we will do volume of gas divided by molar volume of gas. Typically, like in the previous question, we use 24 dm cube per mole for any gas. But we know that if given the volume in cm cube, we have two choices. We can either convert dm cube to cm cube. There's 10 to the 3 or 1000 cm cube. Instead, what you could do also is you could also do convert 1 cm cube to dm cube by dividing by 1000 dm cube. Okay, so what I'm going to do instead is I'm going to use the molar volume multiplied by 1000. I'll get 24,000 cm cube per mole. So 1 mole of any gas occupied 24 dm cube per mole is the same as occupying 24,000 cm cube per mole at room temperature and pressure, which means the unit on top there must be cm cube, because you can do math, you can do physics. That means you should have no problem doing this or understanding this particular calculation. So there's the mole of O2 molecules. So the number of molecules, as I've shown in one of the earlier question, is just Avogadro constant multiplied by your actual number of mole. So that multiplied 6.02 to the power of 10 to the 23. That gave me 1.25 times 10 to the 22 O2 molecules. So there's going to be option A there. So let me just circle option A there. Question 8, empirical formula. Definition of empirical formula is stated in the syllabus. It's the simplest whole number ratio. Simplest whole number ratio of the atoms. So you got to look for something that cannot be simplified further. I can show you which one can be simplified further. This one can be simplified further, and you get HO like that. This one can be simplified further, and you do divide by 2 and you get you divide by 6 and then you can get CH2 6 like that. This one can be simplified further, you divide by 2 and you get 2 carbon for hydrogen. This one cannot be simplified further. This is the simplest whole number ratio of the atoms. Question number 9 is again about empirical formula, but here you need to do a bit of calculation. So in your paper 1 kind of setting, you need to be able to do a calculation very quickly. So I'll just label as well. So despite trying to do things very quickly, do not lose your standard. So N refers to mole. So mole is 85.7 over 12 because it's mass over mR. So 85.7 divided by 12, I get 7.14, I get 14.3. Do not write things like that. You need simplest whole number ratio. So you divide 7.14 divided by 7.14, you get 1 because divided by itself, and this thing is going to be rounded up to 2, which means your empirical formula, your simplest whole number ratio of your formula based on this data is going to be CH2, and there's no way you can get the molecular formula unless you know the MR, and there will be one of the questions that will feature later on. Unless you know the relative molecular mass, there's no way you can get the molecular formula just by knowing empirical formula. So CH2 is the answer there. Number 10, so camphor is just a white solid there that contain the same percentage by mass. This is stated in the syllabus, how to calculate percentage by mass. Percentage by mass is basically how many atom of that you have, so number of that atom multiplied by the relative atomic mass of that atom, that particular atom that you want, divided by the total MR, well basically the MR I guess, times 100%. So it's the mass composition, so it's just basically the relative molecular mass for the whole molecule, for the whole compound, and then how many of that particular atom that you want. For this case is hydrogen, so it's the number of hydrogen times the relative atomic mass of hydrogen divided by MR times 100%. For oxygen, it'll be how many oxygen you have in that compound or molecule times the relative atomic mass of that oxygen divided by the relative molecular mass, which is the mass for 1 mole of the substance. The mass for 1 mole of the substance, which you obtain by summing up the individual relative atomic mass. So let's work out the relative atomic mass for each of these first. For the first one, 12 times 10 plus 6 plus 16 times 6, I get 222. Second one, I get 144, and third one, 12 times 10 plus 16 plus 16, I get 152. Then 10 times 12 plus 10 plus 16 times 2, I get 162. So the percentage of hydrogen is going to be 6 times 1 over 222 times 100%. So all of these will be times 100%. I'm just looking for this thing being the same. Then they will give me the same percentage by mass of hydrogen and oxygen. So without calculating a value, I think I should be all right. Let me just work very quickly for the percentage of oxygen for this option A there. So there is going to be, oh my god, I'm running out of space really. Doesn't matter. So let's try and squeeze in. So I have 6 times 16 over 222 times 100%. So I hope you can see the idea is that there's 6 oxygen. So each oxygen has a mass of 16, relative atomic mass of 16. So divided by the total mass, total MR times 100%. Looking at that, I can tell that they are not going to be the answer because 6 times 1, 6 times 16 are different. When the bottom are exactly the same, the top are different, they are not going to be the same according to the question there. So that's how you can be quick with this kind of question. So looking at the next one, the percentage of hydrogen for B in green is going to be 8 times 1 over 144 times 100%. But then you also have percentage of oxygen, which is going to be 1 times 16 over 144 times 100%. By the same techniques, 1 times 16 is 16, 8 times 1 is 8. The bottom is exactly the same. The top are not the same, so they cannot be equal. So let me try and work out for C. So for C, the percentage of hydrogen is 16 times 1 over 152 times 100%. I think I can see C is the answer because the percentage of oxygen is 1 times 16. There's 1 oxygen. The mass, the relative atomic mass of 1 oxygen is 16 divided by 152 times 100%. I so happen that I have 16 hydrogen, so 16 times 1 there. You can see that this is going to be equal because that bit and that bit are equal. So without actually pressing my calculator, I can see that they must be equal, which means D must not be the answer. As you could see, 10 times 1 is 10 on top, 2 times 16 is 32 on top for the oxygen. So 32 and 10 are not equal. You want the same percentage by mass there. Question 11 is again about empirical formula. So I have, I want PbC8Hx. I want to know how many hydrogen in this simplest whole number ratio for this thing. So I've got Pb, I got carbon, I got hydrogen. So in terms of masses, so I have 29.7% carbon, I have 6.19% hydrogen, but I have three things. I don't know what is the mass of these, but considering these are percentage is marked out of 100, just like your exam, marked out of 100%. So this is going to be the difference from 100% minus the sum of these two. So 100 minus bracket 29.7 plus 6.19. The difference there is 64.11%. And that will give me the mass per 100 gram. So I need to find the relative atomic mass of lead. So straight to the periodic table. Let me have a look. So lead is in group 4. The element quite far at the bottom is 207. So you can just put in 207 like that. So 29.7 there divided by 12, 6.19 divided by 1. So that is small, and you want to label your thing clearly despite you being in a multiple choice paper, because you never know when the time comes. You want to check your answer, and it's a bad habit if you are not a systematic person, because if you are not systematic here in multiple choice, you are going to bring your bad habit into your theory paper as well, and that will be problematic in the long run. So I'm dividing by the smallest number, which is 0.310 throughout, in order to get the simplest whole number ratio. That gives me 8 to the nearest whole number. That divided by 0.310. And I get 19.97, so that gives me 20. So that's going to be Pb1C8H20. So I'm looking for X being the number of hydrogen atoms, so there must be option D there. Question 12 is about percentage composition by mass. So be careful. As I said earlier, percentage composition by mass is how many of that atom you have times the relative atomic mass of that atom divided by the MR of that compound times 100%. So, we just need to get the correct formula first of all. Calcium hydroxide, calcium 2 plus and OH minus, calcium nitrate. So you have problem with this question if you don't know formula, and that's usually the first step in this kind of questions. So the MR of calcium hydroxide, the bracket means 2 times whatever is the sum inside the bracket. Calcium being 40 times 1 plus 2 times bracket 16 times 1 plus 1 times 1. So it's 2 times 17, give you 34. 34 plus 40 give you 74. So with nitrate, I would suggest you to do the one inside the bracket first. So 1 nitrogen, 14 times 1 plus 16 times 3, I get 62 inside the bracket. Multiply by 2 because nitrate is NO3 minus. You need 2 of the nitrate to balance out the plus 2 charge of the calcium. So you need to add in another 40 for the relative atomic mass of calcium there. The MR of calcium oxide, 40 plus 16, give me 56. The MR of calcium sulfate, Ca2 plus SO4 2 minus. This will be one of these days that like if you think knowing the formula is not important, they will not be given an exam. In cases like these, you're kind of doomed if you don't know formula, if you don't know how to work out MR. And of course the last step is the percentage by mass. So we're looking at how many calcium here. In each of these, there's 1 calcium. So there's 1 calcium, which is 40 over 74. for A times 100%, and then you have 40 over 164 times 100%, you have 40 over 56 times 100%, and you have 40 over 136 times 100%. So each of these will be times 100%. I just didn't bother to write them down because I want you to see the trend. The trend here is about the calcium. In the formula, there's only one calcium, so it's 1 times 40. So nothing on the top is changing at all, which means, and times 100% is also the same, which means if we want the 54.1, this is not a question of greatest or smallest. If it's greatest or smallest, we can just compare the value at the bottom and to see which one will be the biggest and the smallest in terms of your math. But this one is very exact, 54.1%. So press your calculator, 40 divided by 74 times 100%. I already got 54.1 for the first one, which means A was already the answer. I really shouldn't waste my time work out the rest. I should work through one by one. And once I got the answer and I confirm it's the answer, I shouldn't have to check the rest at all. Question 13 is about a balancing equation. So calcium oxide reacts with P4O10. So calcium oxide reacts with P4O10, and you're gonna get calcium phosphate according to the question, which you can read because there's calcium 2 plus ion, group 2. Phosphate is PO43 minus, and as such you need 3 of these and 2 of these, because as mentioned in the previous question again and again, you should be able to do lowest common multiple of primary school mathematics. That actually is the basis of this cross multiply method, the crisscross method. It means 3 of these, therefore plus 2, and plus 2, they will give you plus 6 total for the positive charge. Minus 3, you need 2 of these, minus 3 and minus 3 give you minus 6 total for this negative charge. Ionic compound, covalent compound, all compounds have no charge at all. In addition to this calcium phosphate, you don't produce any other thing. This is the only thing you produce. Alright, so they are saying how many mole of calcium oxide react with 1 mole of P4O10. So you can't change this number here. So there's 4 phosphorus, there's 2 phosphorus here, so you put a 2 in front. So you got 3 times 2, so 6 calcium. So I have 6 calcium there. I think I already got my answer, but let's just double check. So O10 plus O6 is O16. O4 times 2 is O8. 8 times 2 is 16. This equation is balanced nicely because you got the correct formula based on the correct starting material. Question 14, they give you the information lead to nitrate, so you know Pb2 plus, NO3 minus, so you need 2 of them. And then you have K plus and NO3 minus, so you just need 1 of them because it's plus 1 and minus 1. But you get a yellow precipitate, which is this thing called lead to iodide, because it has got to be Pb2 plus still and Xi minus. So as you could see, when you do the crisscross, you got 1 of the Pb2 plus to cancel out the charge of 2I minus like that. So what is the equation for this reaction? So you got PbI2. So all of these have got the correct formula. It's just about balancing equation. So here, if you read it correctly, you got 2 nitrate. Here you only got 1 time NO3. When we balance polyatomic ions, we care less about charges. We care more about counting and seeing the whole unit. This was back in the lesson tutorials on balancing chemical equations, and there was also associated tutorials on the work that was given coupled with that particular lesson, which you have done, which you have submitted, which of course you did it yourself, so you know what was going on. So A cannot be correct there. So again, for the same reason, there's 2 nitrate, there's only 1 nitrate there, so B is also wrong. So looking at that, I have 2 times 2, which is 4 nitrate, and I only have 2 nitrate there because 2 times 1, so only 2 times NO3 on the right hand side, but you got 4 times NO3 on the left hand side, so C is definitely wrong. Once A, B, and C are wrong, you spot the mistake. That means D must be correct. 2 NO3, 2 NO3, 2 potassium, 2 potassium, 2 iodine, 2 iodine, 1 lead, and 1 lead there. Question 15 is about balancing equation again. So here you might want to balance from scratch. They don't tell you how many hydrogen there is here, but I guess what you could do is let's total up the number of carbon first. Carbon is already 4 carbon and 4 carbon, so that's easy. The number of hydrogen on the left hand side, what do I have? I have W plus 1 because I have 1 hydrogen plus W. There's no hydrogen there. On the right hand side, I have 2 times Y. So what can I say? W plus 1 equal to 2Y. Well, let's check. W plus 1 is 9. So W plus for A, W plus 1 is 9. 2Y is 8. So you know A is definitely wrong already. B, W plus 1 is equal to 9. What am I doing? Oh yeah, okay. So there's 9 on the left, and then on the right, 2y is equal to 8. So again, that is not balanced. If I look at C, W plus 1 equal to 9. 2y is equal to 2 times 5, which is 10. So 9 does not equal to 10, which is wrong. If you look at D, which means D must be the correct answer, W plus 1 equal to 10 on the left-hand side for the number of hydrogen, and then 2y is equal to 10 on the right-hand side. But of course, you should probably check X as well. X is the number of oxygen, which is 7, they say. And they say if there's 7 and Y is 5, so what do you have? You have 4 times 2, which is 8. 8 plus 5 times 1, which is 13. Is it 13 altogether? Let me double check. So there's 14. 7 times 2 is 14, plus 1 is 15. Whereas here, maybe I've done a mistake. I think I've done a mistake because that doesn't look right at all. Let's see this. Oh wait, okay, I think I made a mistake. Okay, let's start again. That doesn't look right at all. So what have I done wrong? Okay, let's see. If you try to balance this from scratch, let me try writing the equations. So C4H8OH plus 6O2 giving you 4CO2 plus 4H2O. So this is A. Can we see what is wrong here? So 8 plus 1 is 9, and you got 4 times 2, which is 8. So A is wrong. Okay, in terms of hydrogen. And how about B? If you have C4H9OH plus 6O2 giving you 4CO2 plus 4H2O. So let's see what is wrong here. 9 plus 1 is 10 hydrogen. So you got 8 hydrogen only, so B must be wrong. If you look at C, C4H9OH plus 6O2 giving you 4CO2 plus 5H2O. Hydrogen, so that's 9 plus 1, which is 10. So 5 times 2, which is 10, so hydrogen is happy. 6 times 2 is 12, plus 1 oxygen is 13 oxygen. 4 times 2 is 8, 5 times 1 is 5 oxygen. 8 plus 5 oxygen is 13. So we already got our equation C there. That's why when I got the answer as D just now, it was didn't balance out. So that was when I know something was wrong. Okay, so just be very careful there. Question 16 is another balancing equation. So what you could do really is you could put in the number 4NH3. So perhaps if I just do this, 4NH3, 5O2, 4NO there, and then Z being 6. Let's try and balance it. For nitrogen, 5 times 2 is 10 oxygen. 4 oxygen plus 6 times 1 is 6 oxygen. So 4 plus 6 oxygen is 10 oxygen. So oxygen is happy. Nitrogen is happy. How about hydrogen? 4 times 3 is 12. And then 6 times 2 is 12. So I'm pretty sure that we already got our answer from part A there. Therefore, we do not need to check for the rest of them. Okay. Question 17. So we are looking for the mass of aluminium. And this is in 204 grams of Al2O3. This is kind of related to percentage composition by mass. It is saying that instead of out of 100%, it's out of 204 grams. So this is going to be MR of Al2O3. So straight from your periodic table, Al2O3, so there's 27 times 2 plus 16 times 3, so there's 102. So what we have then is the mass of aluminium instead of percentage by mass of aluminium. Out of the total MR, which is 102, you have 2 aluminium, each of which has a mass of 27 gram per mole, times, instead of times 100%, you want to know out of 204 grams. So out of 204 gram, so 27 times 2 divided by 102 times 204, I get exactly 108 gram there. Okay, let me see if I can move that a little bit there, and that thing should be able to squeeze just there. So 108 gram is our answer there. Number 18, so this is a balance equation given. So in terms of balance equation given, I have phosphorus. I want to know phosphorus trioxide, which is P2O3. So, I can set up my mole ratio as you have seen in all your exercises and all the lessons associated with this, which of course you have revised fully prior to doing this test. So label stuff properly, could be the other way around, doesn't matter. Then look at the balance equation, which you must have. P2O3 there is 2 mole, so I put 2 mole on top. P there is phosphorus, so it's 4 mole, so I put 4 at the bottom. Follow your label. So this is mass of phosphorus. They want the mass of phosphorus trioxide. So they want the mass of phosphorus trioxide. I need the MR because mass of MR equal to mole. I'm just following the label that I have done. So 31 times 2 plus 16 times 3, there's 110 gram per mole. And then the AR of phosphorus from the periodic table is 31. So looking at this P2O3 on top, mass over the MR will give me the actual mole of the P2O3. At the bottom is the actual mole of phosphorus, so 6.2 divided by 31. And now I just need to rearrange my equations. So 2 over 4 times 6.2 over 31 is the mass of P2O3 over 110. Of course, then I can move the 110 on top as well. So I'm running out of space here, but anyway, so mass of P2O3 is equal to all of these times 110. If you want, you could have done everything in one step. I would have done everything in one step, but this is the first question in this tutorial on this kind of thing. So what I'll do is I'll just show it in greater detail first, but later on you'll see me taking some shortcuts, which you should be able to do once you're more familiar and more expert with this kind of calculation. Question 19, so people are advised to eat less than 6.0 gram of salt. So table salt is sodium chloride, so there's NaCl. And what mass of sodium is present in 6.0 grams of sodium chloride? So this is similar to the previous question, which was what mass of aluminium is present in here. It's related to percentage composition by mass, but instead of multiplying by 100%, you multiply by the mass that you need. So here, instead of doing percentage composition of sodium, I want the mass of sodium. It means out of the 6 gram, how many gram is actually sodium? Well, you need to find the MR based on the correct formula. So there's NaCl, 23 plus 35.5, you get 58.5 gram per mole. So out of 58.5, how many sodium you have? You have 1 sodium, each of which is 23 gram per mole. So 23 divided by 58.5, instead of multiplying by 100%, you multiply by the mass of that table salt, then you can get the mass composition instead of percentage composition. So these 3 significant figure based on the data given, 1, 2, and 3 significant figure. So there's option B there. Question 20 is another of these kind of mole calculation. So I have aluminium powder. This is excess barium nitrate. If barium nitrate is excess, I do not care about it because not all of it reacted. I want the mass of barium oxide, so I want that. So I have that and I want that. So set up your mole ratio. So the mole of barium oxide is to the mole of aluminium. It's going to be 3 mole of barium oxide to 10 mole of aluminium. Straight from the balance equation, follow what you label on top, follow what you label at the bottom. You could have gotten the other way around, no problem. There will be 10 over 3. On the right hand side, put in the actual mole. So I have the actual mole of aluminium that reacted. So there's 5.40 divided by the MR, well, the AR because it's an element. Mass of AR give you the mole. I want the mass of barium oxide, so I have the mass of barium oxide divided by the MR of barium oxide, which I need to go to my periodic table. So barium is in group 2. At the very bottom of group 2, barium has a symbol Ba, so it's 137 plus 16 for the oxygen, so it's 153. So there's mass divided by 153. Mass over mR give you the actual mole of barium oxide, which you get from reacting an actual mole of aluminium. Rearranging your equations, I hope you can see mass of barium oxide is 3 over 10 times 5.40 over 27 times 153. So I've taken a shortcut there and do everything one step. If you can't see that, then you need to do it in one more step, just like the previous questions, so you can see that. Don't forget unit, because based on that formula, expression there is in grams, so it's 9.18 gram. I've never gone wrong when I set up my equation like this. It's really up to you if you want to do it this way or any other way, as long as you can get the correct answer. But I would suggest that I've never ever gone wrong with these. We've already gone through so many of these kind of variations involving gases, solutions, solid, across the many questions you have done throughout the lessons as examples, and also your own work, which of course you have done, and that's why you could do all these tests on your own. Question 21. So we have nickel making up 20% of the mass of a coin. So if your coin is 10.0 gram, out of the 10.0 gram, what is your mass of nickel in that coin? It's going to be 20%, which is 20 out of 100 times 10.0 gram. So there's actually just 2.0 gram of the coin is actually nickel. Now they want the atoms in the nickel coin. So the number of atoms is going to be Avogadro constant multiplied by the number of nickel atoms. 6.02 times 10 to the 23 is Avogadro constant. The number of mole of nickel atoms is the mass divided by the mR. So, but we don't have mR because we're talking about element. So nickel is an element, is element number 28 in the periodic table, somewhere in the middle there. Nickel has a symbol Ni. It has got relative atomic mass of 59. So mass is 22.0 divided by 59. This is the mole of nickel atoms times the Avogadro constant will give you the number of nickel atoms. So 6.02 times 10 to the 23 times 2 divided by 59. On my calculator, it showed me a lot of numbers, but I'll just round it up to 3 significant figure because based on the data given was 1, 2, and 3 sig fig. So that's why all these answers and my final answer I rounded up to 3 significant figure, because precision is based on the appropriate number of significant figure based on the data. So 2.04, 2.04, don't know how they get 2.05, but that's the closest I can get compared to the rest of the answers. Okay. Question 22. So we use calcium chloride. Anhydrous means no water of crystallization, but it can absorb water and it can get into a hydrated form. And this hydrated form is a dihydrate because there are 2 water being absorbed into here. So if I write the equation, so there's going to be calcium chloride plus 2 water, and you get calcium chloride dihydrate like this. What is the percentage increase in mass? So, first of all, you increase by 2 water molecule for 1 mole of these. If we work with 1 mole, then you will have the MR. So in terms of MR, then you will have calcium chloride, so 40 plus 35.5 times 2, that is 111 for the calcium chloride. MR is for 1 mole. So for 1 mole of water, you have 18, but you have 2 moles of water, so you have 18 and 18. And for calcium chloride, because mass is conserved, everything on the left will give you everything on the right. Calcium chloride is 111. The dot means you plus what? Plus there are 2 water molecules, so plus 18 and plus 18, and you get 147. What is your increase in mass? Your increase in mass is going to be this one. So therefore, your percentage increase in mass is going to come from the absorption of water, and you're absorbing 2 water, so it's 18 times 2, and this is divided compared to your original mass, because increase in mass compared to the original, so divided by 111 times 100%. So 36 divided by 111 times 100%, you get 32.4%, give or take 32%. There's option C there. Question 23. So you're talking about the masses of NaOH. If you remember, we make a stock solution. So you have NaOH solid, 25.0 gram. And then now you have solution. You put it in 500 cm cube of distilled water, obviously, but you don't know the concentration. Just add water. When you just add water, your mole is the same because everything from the solid goes into the solution that you're making up. So the mole of the solid is equal to the mole of the solution. When you have the solid, you have the mass divided by the MR. So I need to work out the MR of NaOH on the side here. 23 plus 16 plus 1 give me 40 gram per mole. So mass of MR for the left hand side as a solid. This is concentration of a solution because it's dissolved in water. It's a mixture. Concentration is what I want. So concentration in mole per dm cube, because there's the answer given all of these. Concentration in mole per dm cube means my volume has to be converted to dm cube. 1 cm cube converted to dm cube by dividing by 1000. So 500 cm cube divided by 1000 will give me the volume in dm cube. Only when you have mole per dm cube multiplied by dm cube, only then the dm cube and dm cube can cancel. Only then it will give you mole of solution as mole. Only when you do mass of MR, the mass is in gram, only then the unit will cancel out to give you mole of the solid. Anyway, units aside, so you just want the concentration of NaOH as your subject. So what happened is 25.0 over 40, do in the bracket, then you have 500 over 1000 there, which is multiplied, so bring downwards and you will get divide. So I do not try and key in my calculator before my final step, but make sure that in your final step, when you key in your calculator, make sure that you are using bracket appropriately. And as with any calculations, you can always do them twice just to check that you have the same value. With the use of bracket, you might be careless here and there, and of course put down unit in your final answer, even though it's your working. Question 24, so you have etanoic acid. So you have a solution of it that has concentration of 2 mole per dm cube. This means there is 2 mole of CH3, COOH in 1 dm cube of distilled or deionized water. But these are all about masses. So if I have 2 mole in 1 dm cube, so I'm looking at the mole of CH3 COOH is 2 is equal to the mass of the CH3 COOH divided by the MR. I want the mass of the CH3 COOH, so I have the 2 mole multiplied by the MR. So what is going to be the MR of CH3 COOH? There's 12 times 1 because there's 12 there, plus 3 because 3 times 1, plus 12, plus 16 times 2, plus 1. So altogether I get 60 gram per mole. So there's 120 gram of CH3 COOH, and then dissolve that in 1 dm cube of water. Then I will dissolve 2 mole of that in 1 dm cube of water to give me 2 mole per dm cube. 25, this is about neutralization. You have a base, or what you call an alkali, and you also have sulfuric acid, which is your acid. So before you do any calculations, always start off with balanced equation. That's something you have learned in your work. And of course, sodium sulfate, Na plus, and then sulfate come from sulfuric acid. So there's plus 1 and minus 2. So this is your lowest common multiple again. So what this means is Na plus, you need 2 of Na plus to balance out the charge of 1 SO4, 2 minus. So Na2 SO4, and then H2O, you need 2 NaOH to balance the equation. That's going to be your first step when the equation is not given. You want the concentration of the dilute sulfuric acid. So I will set up my mole ratio. The mole of sulfuric acid is to the mole of sodium hydroxide. 1 mole of sulfuric acid reacts with 2 mole of NaOH. Because there's 2 H plus in here, you need 2 OH minus, of which the 1 NaOH can only give you 1 OH minus. That's why you need 2 of them. Anyway, that is from the balance equation. Now on the right hand side is your actual number of mole. Your actual number of mole of sulfuric acid is 24.6. Sulfuric acid is on top, so I put information for sulfuric acid on top. You can use divide by 1000. I have decided to use standard form. It's entirely the same. You should be able to press this on your calculator, because sooner than later you'll be pressing this for physics as well, or also in the paper 3 practical studies. So make sure you know divide by 1000 is the same as times 10 to the minus 3. You must be able to press this on your calculator correctly, and this is multiplied by the concentration of H2SO4, which is given in mole per dm cube, which is why my volume there has to be in dm cube. At the bottom, I have 25.0 cm cube of NaOH, which I convert to dm cube by multiplying by 10 to the minus 3, then multiply by the concentration in mole per dm cube. Again and again, dm cube and cm cube do not cancel, so you have to convert that volume in cm cube to dm cube in order to cross out the unit for mole per dm cube, because at the bottom this is mole, this is mole, this is mole. Concentration times volume in dm cube, concentration times volume in dm cube. You have your unknowns, so you know you can just rearrange your equations. So you're gonna keep this the same and move all of this up there and move all of this down there. So you get half time, move up the bottom bit to the left hand side, and move down the top bit from the right hand side to the bottom, because it's your math. Okay, these are rearranging questions. Only when I'm happy rearranging everything, then I press everything into my calculator. If I press my calculator too soon, I will make a mistake here and there, so that gives me 0.0508 mole per dm cube. That's option A there. Question 26. So this is asking us, if I have my concentration of 0.03 mole per dm cube, what is the mass? So you know, I started from the solid, and now I have 1 dm cube, and this is 0.03 mole in 1 dm cube. There's 0.03 mole in 1 dm cube. What is the mass dissolved in it? Well, if you look at it, if you have 1 dm cube, in 1 dm cube, there is 0.03 mole of Na2CO3. Now, if you know you have 0.03 mole, so mole equal to mass of Mr, so you know the mass of Na2CO3 is going to be the mole, which is 0.03, multiplied by the Mr. So the Mr of Na2CO3, I can just work on the side, look at the periodic table, 23 for the relative atomic mass of 1 sodium times 2 plus 12 plus 16 times 3, I get 106. So that's 106 times 0.03, I get 3.18 gram. Option B there. Question 27. So this is the shell of a chicken egg, make up 5% of the mass of average egg. Average egg has 50 gram. So you know the other mass are all the things that are inside, your egg white and your egg yolk. Assume the egg shell is pure calcium carbonate, so calcium 2 plus, CO3 2 minus, same charge. One of these will cancel one of that. I hope you know your formula good enough to be able to see that. Then you need to neutralize etanoic acid. Etanoic acid. Okay, this is a bit tricky. I might have to give the information for etanoic acid, which is CH3CO2H. So what happened there is etanoic acid has 1 H plus per molecule. So it's going to behave like HCl. So if you have CH3CO2H, when you react it with calcium carbonate, you can donate the H plus and you get CH3CO2 minus, and then you're going to get calcium 2 plus, and we have a problem there already. But you also get CO2 and H2O. We have a problem here because when you donate the H plus, you get a -1, which means to cancel out the +2, you actually need 2 of that. If you have 2 of these, it means you must have 2 of that acid as well. And CO2 come from here, and you get the H2O, so 2 hydrogens, and 1 oxygen from there. 2 of the oxygen goes to carbon dioxide. This is your balance equation. Now the calcium carbonate comes from the shell, but the shell is only 5% of the mass of average egg. So the mass of calcium carbonate, the shell, which is going to be just 5%, which is 5 over 100 times your 50 gram. So 5 divided by 100 times 50 gram give you 2.5 gram. Out of 50 gram is the shell, it's the calcium carbonate. This is 2.5 gram in one egg. In one egg, this is in one egg. So let's have a look at the balance equations and try to do some meaningful calculations. Not too sure if that will work. Let me move this down a little bit. I want to move this general information on top there. Okay, so what do we know? We know that the mole of calcium carbonate is to the mole of the acid, the etanoic acid, is 1 mole of calcium carbonate reacts with 2 mole of that acid, and then you're going to put an actual number to it, the mass of calcium carbonate reacting, and you have the MR of calcium carbonate. So there's 40 times 1 plus 12 times 1 plus 16 times 3, you get 100. So mass of MR will be mole of calcium carbonate that actually reacted, and you need this much acid, volume, and concentrations. So 50 times 10 to the minus 3, because to convert the 50 cm cube to dm cube, only then you can multiply by the concentration in mole per dm cube. So work out your calcium carbonate mass by doing your correct rearrangement like that. I hope you can see that. You move everything at the bottom to the top, and then you move up the 100 as well. So there's 0.5, because you still have this ratio. Do not forget it when you rearrange your stuff. Times 50 times 10 to the minus 3 times 2 times 100. I get 5 gram. Now what does this represent? This is the total mass of calcium carbonate that's required. Just now I have 2.5 gram in one egg. So 5 gram is therefore 2 eggs. I need 2 eggs in order to give me 5 gram of calcium carbonate that will neutralize exactly this much etanoic acid based on this balance equation there. Very, very tricky question. Question 28. So we have this hydrated because there's this dot there. It's called water of crystallization. We've covered a couple of questions on this. You should have become familiarized on what this means in terms of MR. You just work out the MR of these plus 1 MR of this H2O. What you're trying to do, you want to get this concentration of NH4 plus. Be careful, there's 2 times NH4 plus in the formula unit. So what do we know? The solid to the solution. Okay, the solid to the solution. I think this question is a calculation, so perhaps I think it's best if I actually show you an equation. So if I have that, and then you have water, you're gonna get NH4 plus, and then CO3 2 minus, and then water as well, something like that. So it's going to become aqueous. Remember, all ammonium salts are soluble in water. All ammonium salts are soluble in water, so they can dissolve in water. But there are 2 NH4 plus, so importantly, I get 2 NH4 plus like that. So that's going to be my balance equation. Balance equation is going to be very important here. Let me see if I can move that down a little bit, or there a little bit. Nah, I'll probably move that over here a little bit. Does that seem alright? Forget about that. Plus H2O liquid. Okay, doesn't matter. So the mole of NH4 plus is to the mole of that solid is going to be well, I have 2 mole of the NH4 plus coming from the solid. So coming from 1 mole of the solid give me 2 NH4 plus. There's our important mole ratio there. I have the solid, I want the mass, so I need the MR of that solid. Okay, let's look at NH4 inside the bracket first. 14 times 1 plus 4 times 1 give me 18. 18 times 2 give me 36, 36 plus 12 times 1 plus 16 times 3. I get 96 for the ammonium carbonate. Let me just check again. Yep, 96, and I've got one water molecule, so it's plus 18 there, time 1, so 96 plus 18 give me 114. So what I have at the bottom there is the mass of the solid divided by 114 will give me the actual mole of solid that dissolved. To give me this particular volume, 800 cm cube, convert to dm cube by dividing by 1000, which is what I'm doing by times or by multiplying by 10 to the minus 3. So that volume is in dm cube now. Now multiply by concentration, because volume times concentration, this is in dm cube, this is in mole per dm cube. That will give me the actual mole of the solution. Now my unknown is at the bottom there, so I'm going to move up the solid. So the mass of the solid over 114 is going to be all that 800 times 10 to the minus 3 times 0.100. Don't forget, I'm going to move down the 2, so cross multiply, move down the 2 and move all of this up. Now I can also move up the 114. So when I cross out the 114, it's going to go to the other side and multiply by 114. There you go, I've got my equations all set up. So just putting everything to my calculator now. I got 4.56 gram. If you can't see that all in one go, do it step by step. All right. Question 29. So you start with 90 gram of glucose is dissolved in water. You are given these reacting masses. The MR is 180. So in terms of reacting masses, if you have 180 and then you have MR, which is for 1 mole, and yet you're producing 2 mole. So you have 46 and you have 46. Altogether you have 46 plus 46, which is 92 coming from this one at 0. And the MR of CO2 is 44, but that is for 1 mole. So you plus 44, that give you 88. So what we are saying is C6H12O6 going to 2CO2 going to 2C2H5OH. If you have 180 gram, then you will have 88 gram there and you have 92 gram there. If you sum up these two masses, they will get 180 gram again. This is the total mass for 2CO2, because 2 mole of it will be 2 times the MR, because MR is for 1 mole, gram per mole. That's the unit, that's the definition. After the fermentation, so these are based on MR, these are based on MR. So if you want, you can also think about what happens if you react 90 gram. You expect to get how many ethanol? This is the actual yield of ethanol. This is using mass, okay? Reacting mass ratio is not mole. Be careful, yeah? This is actually what combined science students would have done. They're just using reacting masses, but then you can also use mole if you want to. But if you want, you can use masses, as what I'm going to show you here. But you get the exact same answer if you decide to use mole. So this is actual. If you have 180 gram, you get 92 gram there. If you have 90 gram there, so you're going to have half of it. So you're going to get half of that 92, because you're using half the amount of glucose there. So 0.5 times 92, you will get 46 gram. This is expected. Okay, but then how much you actually get, percentage yield means how much you actually get, which is 6.8 gram divided by the 46 gram times 100%. So 6.8 divided by 48, 6.8 divided by 46 times 100%, I get 14.8%, so 3 significant figure. So there has to be option C there. Question 30, so we have calcium carbonate and we have hydrochloric acid. So the first thing you have to do is to write a balanced equation. When the question don't give you, you have to write a balanced equation to get the correct salt formula. 1 calcium 2 plus, balanced out by the charges with 2 Cl minus, and you get CO2 and H2O. Don't forget, because of this formula, CaCl2, you have 2 chlorine, so you need 2 HCl. Our balance equation shows that the mole of calcium carbonate is to the mole of HCl is 1 mole calcium carbonate reacting with 2 mole HCl. I'm going to put in the actual mole of calcium carbonate now. This is 2 gram. This is mixture. Okay, this is mixture. Mixture, basically, not all is calcium carbonate. But then, how much calcium carbonate is in there? So that's what we are trying to find. And if you work out the MR calcium carbonate, I've done it previously, 40 plus 12 plus 16 times 3, give me 100. There's the actual mole of calcium carbonate that reacted. And I've got the volume. This is in cm cubed, so 36.0 times 10 to the minus 3. To convert the cm cubed to dm cubed, divide by 1000 is the same as times 10 to the minus 3. And that is multiplied by 0.500. Concentration times volume, or volume times concentration for solution, is the actual mole of HCl that reacted. Rearrange your equations, and I hope you can see what I'm doing here. The mass of calcium carbonate is going to be equal to half times 36.0 times 10 to the minus 3 times 0.500 times 100, because I'm going to move up the 100 there as well in one single step. So half times 36.0 times 10 to the 3 times 0.5 times 100, I get 0.9 gram. Now out of the 2 gram, only 0.9 gram is pure calcium carbonate that reacted. So the percentage of calcium carbonate means out of the 2 gram, only 0.9 gram is calcium carbonate. So that is going to be 45% percentage purity. So that's option B there. Question 31 is basically just reading the statement. So these are gaseous, and gaseous. So we can think about volume ratio of gas, only for gas, is equal to mole ratio of gas. And that is because the mole of a gas is equal to volume of a gas to the molar volume of gas. And this is constant. This is constant for all gas under the same conditions. For example, at room temperature and pressure, that is a volume of 24 dm cubed per mole. What do we know? If we look at statement number 1, if we had 10 cm cube of propane, then how much oxygen is required? 1 mole of these require 5 mole of these. So 1 volume of these require 5 volume of these, based on this idea about volume ratio of gas is the same as mole ratio of gas, but only for gas. Okay, so that will require 50 cm cube of oxygen. So cannot burn if less than that much oxygen is present. So A is actually correct already, because 10 cm cube of this will require 50 cm cube. If you have less than 50 cm cube, cannot burn. Cannot burn because cannot combust is the same thing. Cannot combust if you have lesser than that, based on the balance equation. Let's just check what is going on. So they're looking to try and confuse you. If you look very importantly, I've circled liquid, not gas. So we can't do volume ratio of gas being mole ratio of liquid. So 40 cm cube of liquid water is wrong, because it's not a gas. So we can't deduce that from there. If you have 20 cm cube of propane, so if you have 20 cm cube of propane, how much oxygen is required? If you have 1 mole, you require 5 mole. If you have 1 cm cube, you require 5 cm cube. You require 5 times the volume. So you will need 100 cm cube of oxygen. Did I? Oh no, A cannot be the answer. A cannot be the answer, because I just realized something. They say that A say cannot burn, right? Cannot burn. Can burn, but incomplete. Basically, it doesn't follow this equation. Okay, this is forming carbon dioxide and water. So 50 cm cube is required for complete combustion of 10 cm cube of C3H8 propane there. This is a tricky question. They say cannot burn. Cannot is actually wrong. It can burn, but it will be incomplete, meaning to say they might not just form carbon dioxide. Oh my god, I was so tricked there. Anyway, doesn't matter. I found the correct answer by going through the other one anyway. So 100 cm cube oxygen would be sufficient to react completely Completely means complete combustion. And if you have 20 cm cube of C3H8, you need 5 times the volume to react completely to give you carbon dioxide and water. So C is actually the correct answer there. And these reactions will result in the increase in the volume of gas. If you look at the left hand side, you have 1 mole plus 5, you have 6 mole of gas on the left. On the right, you have a total of 3 mole of gas. So going from 6 mole of gas to 3 mole of gas, this is a decrease in the mole. So this is decrease in volume of gas. So increase is wrong, should be decrease there. Okay, be very careful. Question 32. So we have given this information that we have excess sodium carbonate. That means we are not going to use any information related to this sodium carbonate in our mole calculations, because we are being asked on how much product, which is carbon dioxide, is being produced. So your product come only from the reactants that fully reacted, which is based on these. Whenever you're given information on basically both the reactants, you always have to work out which one is completely used up and which one is in excess. Here it so happened that the question asks you specifically to use these rather than the excess one, because they don't give you any information for the excess sodium carbonate. So yeah, very popular kind of questions. Carbonate acid, salt, carbon dioxide, and water. Getting the correct formula would mean that you have gotten the balance equation, most likely. So setting out a mole ratio, so a mole of carbon dioxide is to the mole of the HCl. 1 mole of carbon dioxide comes from 2 mole of HCl. 1 mole of carbon dioxide from 2 mole of HCl. Follow the label on your own work, and you have this much volume and this much concentration of HCl. So what you have is 10.0 times 10 to the minus 3. You convert that into dm cube by multiplying by 10 to the minus 3, or just dividing by 1000. It's the same thing as converting cm cube to dm cube, and then what you do is multiply by 0.10 mole per dm cube. So what you have there then is you need the volume of carbon dioxide gas, so that's volume of CO2, and you divide that by 24,000. The reason why I do 24,000 is because in each of these options, they've given us cm cube. So we can think about molar volume of a gas, which is 24 dm cube per mole of any gas at room temperature and pressure. This information is given for free in the periodic table, although you should have known this as part of your course anyway. This is also equal to 24,000 cm cube per mole of any gas, and that's exactly what I'm doing here. If I use 24,000, it means that the volume there will be in cm cube. So rearranging your equation, volume of CO2 will be a half times 10.0 times 10 to the minus 3 times 0.10, and I need to move up the 24,000 as well. So I'm squeezing in the numbers here. So all of these going up, multiplying by a half, and then that is equal to this divided by 24,000. I can move out 24,000 in one step, and therefore I can just key in my calculator now. If you can't do all of that in one step, no worries. So instead what you do is you do it step by step, and as long as you can get to the correct answer, no one's gonna care how many steps you take, as long as you know that you can do it in about 1 to 2 minutes in the real exam. Question 33, so we have this equation here. So this is sodium azide, NaN3 is sodium azide. We have 50 grams of this, and we want the volume of nitrogen that is being produced. You want volume of N2 gas, so we have to relate the mole of N2 is to the mole of NaN3. So 3 mole of N2 comes from 2 mole of NaN3 according to the balance equation. That's the first thing we would do in this kind of questions. So we want the volume of nitrogen gas. They don't tell you it's nitrogen gas, but you know nitrogen is a gas at room temperature and pressure, and therefore we can do divided by 24. This is 24 dm cube per mole. I use 24 because each of this volume is given to us in dm cube, and our job is to find out what is the volume of N2. They will be liberated, they will be given out, they will be produced by reacting 50 grams of sodium azide. So gram there refer to mass. That means I need the MR of sodium azide. So there's 23 plus 14 times 3. They give me 65. So mass over mR, 50 over 65 is the actual mole of sodium azide that reacted, and I want to find how much actual volume of nitrogen that actually get produced. What you do then is you bring all that up, so it's 3 over 2 times 50 over 65, and don't forget it's actually equal to volume over 24. I'm bringing out my 24 all in one step, and my final answer will be in dm cubed because of how I have set up my equations by dividing that thing by 24 dm cubed per mole. So my final answer is actually in dm cubed, so 27.7 dm cubed, like that. 34, so we're given these balance equations between nitric acid and potassium carbonate, salt, carbon dioxide, and water. We want the volume of carbon dioxide, and this is from 69 gram of potassium carbonate. So don't know why that didn't underline properly. So I have this thing and I want carbon dioxide. So I need the mR of potassium carbonate, K plus and CO3 2 minus. Hope you can see you need 2 of that and 1 of that carbonate. So 39 times 2 plus 12 times 1 plus 16 times 3, I get 138 for the mR of K2CO3. So setting up my mole ratio, mole of carbon dioxide is to the mole of potassium carbonate. So these are the shorthand notation for the mole. From the balance equation, look at the balance equation, 1 mole of CO2. So I follow my own label, 1 mole of CO2, 1 mole of K2CO3 from the balance equation. On the other side is the actual mole. I want the volume of carbon dioxide. These are in dm cubed. These are referring to the carbon dioxide gas. So it's the volume of CO2 divided by 24 for the actual mole of carbon dioxide that came from reacting 69 gram of that potassium carbonate. So mass over mR give me the actual mole of that potassium carbonate that reacted. So the volume of carbon dioxide, that is 69 over 138. You go up, you multiply by 1. That means it's going to give you exactly the same thing, which is why I'm ignoring the 1 over 1. And I just jump straight to my calculation, and this gives me 12 dm cubed because I've divided by 24 dm cubed per mole. Therefore, this volume here is in dm cubed. Be very careful, especially when you are in structured paper. Units really matter. Question 35 is about conversion of units. So they're saying that in China, we measure them in millimole per liter, but in Pakistan, they measure the concentration of glucose in milligram per deciliter. Now, liter is 1 dm cubed and deciliter is 0.1 dm cubed. So what is 15.5 millimole per liter converted to milligram per deciliter? 18.5 millimole divided by 1 liter. You want to get into how many milligram over deciliter. If I were you, first thing I would do is convert the mole. So mole equal to mass over mR, and if I want the mass, I will have the mole times the mR. I'm talking about glucose, so the mR of C6H12O6 is 12 times 6 plus 12 times 1 plus 6 times 16. So that gave me 180. So the mass of the glucose is going to be 18.5 millimole, so times 10 to the minus 3 in order to convert the millimole into mole, and then multiply by the mR, which is 180. So the mass is going to be 18.5 times 10 to the minus 3 times 180. So this gives me 3.33 gram, but I want it in milligram, so the mass is going to be multiplied by 1000 because 1 gram is 1000 milligram. So this is 3330 gram. Onto the second bit, I'm looking at in 1 liter. I want to convert to deciliter. How many deciliter is there? So 1 liter is 1 dm cube. 1 deciliter is 0.1 dm cube. So if, how can I look at this here? So what do I have? I have 1 liter. 1 liter is 1 dm cube. 1 deciliter is 0.1 dm cube. So 1 liter is equal to 1 dm cube. 1 dm cube equal to how many deciliter? Well, 1 deciliter is 0.1 dm cube. So 1 deciliter is 0.1 dm cube. What am I looking at? Nope, that's no good. So what can I say? I can say that in 0.1 dm cube, I have 1 deciliter. Therefore, in 1 dm cube, which is 10 times, I will have 1 times 1 over 0.1, which is 10 deciliter. So in our step 3 for this work, I can convert the 18.5 into 3330 gram on top, and then the 1 liter is 10 deciliter at the bottom. So do that on your calculator, you get 333. Oops, sorry, not gram, but milligram, because we follow the units. So it's milligram there because I have times by 1,000 there. From the gram, I'll get the milligram just like that. Let's get that correct. So there's milligram per deciliter. So the answer there must be option C. So just a little bit of math and try to understand the unit conversion there. Question 36 is another one, calcium carbonate plus nitric acid. You have excess of nitric acid. So you're looking at the mass of the product as well as the volume of carbon dioxide gas being produced. And this is limiting because the nitric acid is not completely used up. The limiting one is used up completely. So looking at mole ratio, so the mole of the calcium nitrate, the salt, Ca2 plus, NO3 2 minus, based on the calcium carbonate that reacted fully is 1:1. And I need the mass over the MR, so I need the MR of calcium nitrate. If I just do the nitrate first, so I got 14 plus 16 times 3, this gives me 62 in the bracket, times 2, that give me 124 because I have 2 nitrate, plus 40 because I have another calcium, so the MR of calcium nitrate is 164. So mass of the calcium nitrate over 164 comes from 25 gram of calcium carbonate. So 40 plus 12 plus 16 times 3 give me 100. So the mass of the calcium nitrate, as you could see, hopefully, is 25 over 100 times 164. This gives me 41 gram. So I get these and these being wrong. So could be C or D. And then looking at the mole of CO2 is to the mole of calcium carbonate. Again, it's 1:1 from the balance equation. But I've got volume of CO2 divided by 24 is to 25 over 100 for the mass over MR for calcium carbonate. So the volume of CO2 is 25 over 100 times 24. That is 6 dm cube because this was using 24 dm cube per mole. So just double checking, 0.25 times 24, 6 dm cube. So we're looking at option C and not option D there. Question 37 is about reading statement. So these are gaseous, 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 and gaseous. Earlier on, there's a question talking about these. Basically, the volume ratio of gas is equal to the mole ratio of gas. This only works if you have gases because we are literally talking about the mole of a gas is the volume of the gas over the molar volume, which is a constant for any gas under the same condition, okay, for 1 mole of a gas. So looking at 1 mole of hydrazine, which is, well, N2H4, if you have 1 mole of hydrazine, it gives 72 dm gaseous products because you have 1 mole of N2, 2 mole of H2O gas and gas, so you got 3 mole of gas. 1 mole of gas is 24 dm cube at room temperature and pressure. That is stated in your periodic table for free. The volume of a gas for 1 mole of any gas at room temperature and pressure, you get 3 mole of gas, so 3 times 24 give you 72 dm cube. 1 is correct. If 1 is correct, then C must be wrong, D must be wrong. Looking at A and B, the sensible thing is not to check for number 2 because if 1 is correct, number 2 must be correct. Then I must check for number 3 by logic, okay? Let's check number 3. The total number of atoms in 1 mole of hydrazine is 6 times Avogadro constant. Let's have a look at N2H4. So there are 2 nitrogen atoms. So if I have 1 molecule of N2H4, I have 2 nitrogen atoms and 4 hydrogen atoms. So altogether, I have 6 atoms because 2 plus 4 is 6 atoms. Now if I have 1 mole of N2H4, therefore I will have 6 times Avogadro constant number of atoms, which include 2L, 2 times Avogadro constant of nitrogen atoms, and 4L, 4 times L, which is 4 times Avogadro constant, equal to the number of hydrogen atom. So 3 is definitely correct. If 3 is definitely correct, A must be the answer, because 2 is definitely correct by default if 1 is correct based on this option that have been presented to us. Part of thinking skill, part of the logic in tackling this kind of multiple choice question. 38, this is about the mole of ethane. The ethane is C2H6, I have that. I want to know the mole of carbon dioxide. So again, it's mole ratio. The mole of carbon dioxide is to the mole of ethane. From the balance equation, 4 mole of carbon dioxide come from 2 mole of C2H6. Label it like that, and then put in the actual amount of ethane that burns is 0.5 mole. And then I want the volume of CO2. This is divided by 24. I use 24 because all of these volume are given to us in dm cube. So I will use molar volume of gas, which is 24 dm cube per mole of that particular gas, as stated previously again and again. So make that volume of CO2 as the subject of formula. So bring up the 0.5 and then bring up the 24. Hopefully then you could get 24 dm cube. And there is the answer there. Question 39, so getting to the end now. So this reaction has a 30% yield. So this means if 1 mole reacts with 3 mole, you expect to get 2 mole. But what happens is you only get 30% of 2 mole because 30% yield is reality here. So what volume of ammonia gas is obtained when you react this much with excess nitrogen? So nitrogen is not useful because it's excess. So the mole of NH3 is to the mole of H2 is 2 mole of NH3 obtained from 3 mole of H2. Now if I react 0.75 mole of hydrogen, this is what I expect from 100%. This is from 100% reaction, 100% yield of reaction in this ratio. Anyway, let's work out the NH3 expected at 100% ratio. So bring up the 0.75. So 2 over 3 to divide by 3 times 0.75, I get 0.5 mole. Now they want the volume. Before I do the volume, I need to think about percentage yield. Is only 30%. So actual, what is the actual mole of NH3 obtained at 30%? So it's 30 over 100 times what I expect to get. So 0.5 times 30 divided by 100, I get 0.15 mole. And this is mole of ammonia gas. And this is the actual mole based on the actual yield. I want the volume of the gas, so the volume of NH3. These are all answered in cm cube. So I will do division by 24,000 cm cube per mole instead of 24 dm cube per mole. Then I can get 0.15 times 24,000. And I get the final answer is 3,600 cm cube because I've used that thing divided by 24,000. So I will have 3,600 cm cube there. Finally, onto the last questions. Question 40, calcium carbonate plus hydrochloric acid. Make sure you know how to get the formula based on the, well, you know the ions, and you get the salt, carbon dioxide, water, balance equation as usual. So here, you are given information for both reactant. When you are given information for both reactant, the first thing you do is check which one is completely used up and which one is in excess. So the mole of calcium carbonate, given the mass there, is mass divided by the MR. I have done so many of these MR for calcium carbonate. You can check it for yourself. 40 plus 12 plus 16 times 3 is 100. And they give me 0.10 mole of the calcium carbonate. Everything should be labeled so that you yourself are not confused of what you're supposed to be doing. 100 times 10 to the minus 3 means 100 over 1000 to convert the volume in cm cube to dm cube before you multiply by the concentration, which is 1 mole per dm cube. So I'm not going to write down the unit, but I hope you can understand the idea of the unit is that mole per dm cube must multiply by the volume in dm cube. That's why you divide by 1000 or times 10 to the minus 3 there. So what I get there is 0.1 mole. And from the balance equation, 1 mole of this reacts with 2 mole of that. So from balance equation, 1 mole of calcium carbonate reacts or needs 2 mole of HCl. So what do you have? You can think about it one way or the other. Doesn't matter. When something asks you about excess or limiting, you can think about one way or the other, because if one is limiting, the other one is excess. If one is excess, the other one is limiting. So I'll think about 0.10 mole of calcium carbonate. Therefore, how much would that need? That would need 2 times 0.10 over 1. So they would need 0.20 mole of HCl. But in reality, this is what you have. The bottom one is what you need. What you reacted, what you have. This is what you need. So meaning to say, the HCl is not enough to react with 0.10 mole of calcium carbonate. The HCl is not enough. Therefore, HCl is limiting, meaning it's used up. But that also means calcium carbonate is in excess. This kind of calculations, this kind of argument could have been used to explain why calcium carbonate is in excess by going this way, where the HCl is completely used up, or the other way if they want you to find out exactly limiting or excess. Okay, so HCl is limiting. That is very, very important. HCl is limiting, which means in all our calculations, we don't care about the excess reactant after we work it out ourselves. What else? If calcium carbonate is in excess, that means they say no calcium carbonate is left. This is entirely wrong. 4 is wrong. If 4 is wrong, B is wrong. If 4 is wrong, D is wrong. So instead of checking all these 4, option A and option C, I already crossed out option 4 based on what I've done, limiting versus excess. They both have number 2, so I don't need to check number 2. They have 1 or they have 3, so I just need to check for either 1 or either 3, and that means if one of them is correct, the other one is wrong, because there's only one correct answer here based on the options. So option 1 is based on volume of carbon dioxide. Option 4 is based on mass of carbon dioxide. I think I'll probably choose the volume. It doesn't matter really. So if I choose option 1, so the mole of carbon dioxide is to the mole of the limiting reactant. 1 mole of carbon dioxide there from 2 mole of the acid. And then I want the volume of the CO2 divided by 24 dm cube per mole, because this is given in dm cube. At the bottom, the mole of HCl that's completely used up was 0.1 mole. So I just sub in 0.1 mole. So the volume of CO2 in dm cube is going to be half time 0.1, because you bring out the 0.1, that is equal to volume over 24. But I'll bring out the 24 straight away simply because I am expert enough in doing this. If you are not expert enough in doing this, I suggest you to do it stepwise, whatever it takes, as long as you can get to the same endpoint. All right, 1.2 dm cube of CO2. 1 is correct because based on that information, I get 1.2 dm cube of CO2. If 1 is correct, A must be the answer. Okay, that's how we can get A as the answer already without checking for the rest. This is a shortcut way in a multiple choice paper. Cut out what is impossible. This is called elimination method. If you want, you can also check number 3 and you will be able to show that it is wrong. If I just very quickly show option number 3, so the mole of CO2 is to the mole of HCl is 1:2, and I have the mass of CO2 divided by the MR, which is 44, because I'm given I need to find the mass of carbon dioxide for option 3 there. At the bottom is 0.1 mole of the HCl that fully reacted, just like what we did for option 1 there. So the mass of carbon dioxide is going to be half time 0.1 times 44. That give me 2.2 gram, because this is the mass of carbon dioxide. If you look at option 3 there, option 3 there definitely is wrong, because it should be 2.2 gram. C calculations. Okay, So we've reached the end of this particular tutorial on multiple choice questions, 40 questions for this topical test. A bit slightly longer has been allocated for this topical test, but that's because, as you could see when I went through the questions, calculation does take a bit longer. It's impossible for a whole paper to have just calculations in a real exam. Therefore, things have to be accommodated for the students to differentiate different level abilities without jeopardizing the opportunities for students to show what they're capable of. Okay, so thank you for watching. Don't forget to click the button on the bottom right to subscribe to the channel. Follow me at ptet.chemistry. There's at ptet.chemistry on Facebook, Instagram, and Twitter to get connected, send in your inquiries and stuff. And yeah, let me know if you spot any mistakes and stuff. And yeah, comment away and like or whatever on the video. And see you in the next tutorial video. Thank you for watching again.